Hello and welcome to my video, dear students. Today we are going to learn about a very important topic of the computer science syllabus of class 12, that is data structures. If you like the video, please do subscribe and share. And now without any delay, let's start with our topic. So before we begin to learn about the data structures, I would like to tell you what all are we going to see and learn over here. So here we're going to see what are data structures, why are data structures needed, types of data structures in Python, built-in data structures, and the user-defined data structures. In the built-in data structures, we have the list, dictionary, tuple, sets. The user-defined data structures, we have array, stack, queue, linked list, tree, and graph. We are going to see how can we implement the stacks in Python. So before we learn about the stacks, let's move on to the meaning of data structure. Now, what is exactly a data structure? Students, data structure is basically a mechanism to store, organize, and access data. Now, what exactly do you mean by data? Data here is the raw facts, the values. We would like to store a lot of data in computer. Basically, computer is used for data storage and data manipulation. That is one of the most important and important tasks that computer has to perform, which is data storage and data manipulation as well. So this data is to be organized inside the computer. If it is organized, it can be accessed easily. Now, when we want to access data from the computer, what we need to do? We need to perform certain operations. Operations in the sense, we can insert the data, we can delete the data, the slicing part, all those operations which can be performed on list, string, and tuples. We are talking about those operations over here. So basically, data structure, it is a mechanism to store, organize, and access data, but along with the operations that can be efficiently performed on the data. So it's the clubbing of, the storing, organizing, and the operations as well. Now, we have seen string data type in Python. String is a data structure. It contains a sequence of elements where each element is a character. Similarly, we have list, but list is a sequence data structure in which each element may be of different types. Now we can apply different operations like reversal, slicing, counting of elements, etc. on list and string. So basically, list and string, what happens is, if I'm saying they are data structures, that means data structures, list and string, they are able to organize multiple elements in a way so that certain operations on each element as well as a collective data unit can be performed. So herein what is happening, I am not performing an operation on each element of the list individually. It is being performed on collective data. So that forms a data structure. Now, other than the list, string, we have data structures. Other data structures are arrays, linked list, binary, trees, heaps, graphs, sparse matrix, etc. Now, before we move on to our topic, that is the stacks as data structures, let me ask you a question. What does this look like to you? Does this look like an ordered sequence to you? If I wish to remove any book from the middle or from anywhere, will it be convenient for me to remove the book? Does it look like an organized structure? No. Answer would certainly be no. If I remove any one book, the entire pile is going to fall down. Now, in comparison to this, just have a look at this arrangement of books. Here and what is happening, the books are arranged in a linear fashion, one after the other. In case if I wish to remove any book, I can very conveniently remove the book It is not going to disturb the arrangement in any case. If I wish to put any book, I can even put the book inside. So we are talking about an organized structure over here. So as you can see that this is a disorganized structure, and in comparison to it, it is very easy to use. It is quite convenient to use this organized data. It is also an efficient way of storing any entity. Here we have taken books, and then we are talking about, in computer we talk about data. So as I said, the data structures. Now data structures, it is a mechanism to store and organize data. Now we have two different types of data structures. One is the simple data structure. Another one is the compound data structure. Now what is a simple data structure? A simple data structure, the example of a simple data structure is an array. Array consists of elements of similar type. So it is considered as a very simple data structure. Whereas in a compound data structure, we can have elements of different types. Okay. So a compound data structure may be linear, may be non-linear. Now what is meant by a linear data structure? If the elements of the data structure are organized in a sequence, it is called as linear data structure. And in case if it is organized in some different hierarchy, in different levels, then it is called as non-linear. The example of non-linear over here is tree. And the linear data structures are further categorized into built-in and user-defined. Now let's consider the built-in data types. In class 11th, we have already covered the lists, tuples, dictionaries, and the set. These are all built-in data types, as the example was also given in the beginning. Now which data types are the user-defined ones? The stacks, the queues, and linked lists. And the topic that we are going to continue with over here is the stacks. We are going to consider the stacks. Let's now begin with stacks. So in your day-to-day life, children, you must have seen a pile of clothes. I'm sure you must have seen multiple chairs in a vertical pile, or a lady wearing a lot of bangles on her wrist, a pile of books, of eatables in a pantry. All these are examples of stacks. Other examples are pile of plates, a pile of coins, a pile of books, one on top of the other. These are all following a particular structure which is called as a stack. Now why is it like that? Let's see. You must have seen, or you must have noticed, when you wish to add a book or a plate on the top of on a pile, you certainly do it towards the top, and if you wish to remove it, you try to do it from the top only. This arrangement of elements, this arrangement of any objects, it is called as a linear order. Simply because in a pile it is very inconvenient to add or remove an object from in between or bottom. It will make the arrangement improper over there, right? So here also in stack, what happens if we wish to add new elements, or if we wish to remove existing elements, we do it from the same end, and that end is called top of the stack. So this arrangement basically follows a principle which is called as a LIFO principle, last in first out. That is, the element which was inserted last, the most recent element, that will be taken out first from the stack. So let's quickly see now what is a stack. How do we define a stack? See, a stack is a data structure whose elements are accessed according to the last in first out principle. This is because in a stack, insertion and deletion of elements can only take place at one end, that is called as the top of the stack. In Python, we are going to implement the stacks using the list and using the inbuilt functions like pop, to remove an element. Now further, let's have a quick look at where all are we using these stacks in programming. See, one of the very common examples of stack in programming is in reversing a string. When we wish to traverse the string in reverse order, that means from the last character till the first character, okay, that time we use a stack. All the characters are put in the stack and then the last one is popped out first or removed first rather. So this is how the reversing method is implemented. The second example is the computer basically stores all the operations which are undone by a user. If suppose you are editing an image and you know undo several tasks. So where are those tasks stored actually? They are stored in the stack. You know, the recent most editing that has been done on a document or an image is first undone, and the same process goes with the redo as well. The third example is when we are browsing the web. Now just imagine, suppose that you are working on the web and you click on page 1, then you go to page 2, then you browse to page 3. Now if you wish to go to your previous page, the browser has a special button that is called as back. If you click on that back button, you will be taken to the second page, or the second page will be displayed. This is because the history of browsed pages is also maintained as stack. Okay, another example of stack is the arithmetic expressions. You are aware that we use parentheses in the arithmetic operations, and the order of evaluation of operators is determined using the parentheses. So the compiler is always looking for matching parentheses. If it doesn't find a matching parenthesis, it throws an error. So to handle matching of parentheses, stack is used. The two most important operations that can be performed on stack are, adding an element and removing an element. So we have the terms push and pop, and let's see what do they mean now. The removal of element from a stack is technically called as pop operation, and the insertion of element in a stack is technically called as pop operation, push operation. The peek operation basically inspects a value at the stack top without removing it. It is also sometimes referred to as inspection. Now let's quickly have a look at how elements are added. Let's have a look at the diagrammatic representation. So just consider a stack. 1, 2, 3, 4, 5, 6 are the elements. So in the first attempt, element 1 will be pushed in the stack. In the second attempt, 2, 3, 4, 5 and 6, and you will notice that the elements are added on one on top of the other. So in the first attempt, what is there on the top? 1. In the second attempt, 2. So every time we are adding an element, the top is changing over here. Right. Similarly, when we try to remove an element, the pop is changing. The top of the stack is going to change, and here you will see that if we remove 6, 5, 4, 3, 2, so every time the next elements becomes the top. Now there are two conditions that a stack faces. You can assume that in case if there is no space in the stack, if one tries to push an element and the stack or the queue also becomes full. So this condition in programming is termed as overflow. But since we are using Python over here, in Python we use lists, and lists have one property that they can grow. So until and unless all the memory gets exhausted, this condition never arises. On the contrary, we have another condition that is called as underflow. Now, this condition arises when one tries to pop an element in a stack and queue. is empty. If one tries to remove an element from a stack which is not currently having any item, it results in underflow. So in programming, we have to check, whether there is an element in the stack or not. Now just assume that we have a stack of 5 elements. 78, 45, 67, 90 and 65 are the elements. Now just like in other programs, we access the elements using the index numbers. Here also we are going to use the list, and the index numbers will be used to remove, to delete or to access the elements. So we are going to implement the stacks using the list, and in case if I wish to add an element, I am going to use the inbuilt function append over here. We will have a look at it, in the program. I will create a program and I will show you how we can add an element to the stack. So let's move on to the and let's make a program to implement the stack. So the first and the foremost thing what we need to do is we need to create an empty list. I name this list as num and use the list constructor function to create the list. Now I will make an inbuilt function, which will help me to insert an element in the list. I name this function as pop push. I will pass the array, I will pass the stack to it, the list to it, and use the function append to add the value. Now this value can be an element and it is to be passed along with the list as a second argument. So once I do this, you will see that the element that I pass will be appended to the list. But for this I need another part of the program. I need to create an interface wherein a function is called and the element is added into the array. So let me create another function before I make the interface. Suppose I would like to pop the element from the list. So to pop the element from the list, again I will have to pass the stack. But herein please remember, since I am trying to remove an element, there is no need to pass element as the second argument. To remove an element, we will use the pop function of the list, and since we are trying to remove it from the top of the stack, right? If we are trying to remove from the top of the stack, then we have to give the index value as 0. So herein I have written the two functions. Another function that I will require is the display function. So to display the elements of the list, what do I need to write over here is I will have to access the list in backward form. So for doing that, what am I going to do is, first I will find the length of my list. Once I found the length of the list, I will start from the topmost element. I will go in the backward direction by putting -1, and this -1 I'm writing since I want to go from the top to the bottom. So since I'm going to access the list in reverse order, I need to write the same over here for the start value, for the stop value, and for the backward indexing. I need to print the list, right? But herein I will have to put a check. Now what check I need to put? I need to first check whether my list has any element or not. And for that, I will have to create a function called isEmpty. I'm going to pass again the stack to it. And here I will find whether the list has elements or not. So in case if the length of this num results into 0, that means there are no elements, else the function is going to return false. Once we have done that, what we need to do next is we are going to call this function in display. Call this isEmpty function in display. If isEmpty, if it is true, that means our stack is empty or the condition underflow has been encountered. So I will write underflow stack is empty. Now once we have created this function, the next thing that we do is we will call these functions. We will call these functions and we will call these functions and we will write a menu driven program. But for your convenience and to save the time, I have already created a menu driven program. And let me just show you. Now here what have I done? I have created a menu wherein I have displayed the options for push, pop, peek, display and exit. Right? Herein we are going to create a stack of float elements. So I will take the input from the user first and that will be passed on to the push function. You can see I have already written the definition of push function, the pop function, and as per the user's choice, these functions are being called. Once the functions are called, it will execute the code accordingly. I just need to make a change over here since the display function is having a lowercase in the rest of my code. I'm going to put it like that. Okay, now as you can see there's an error over here. I will have to put the code for peek as well. So what is peek going to do in my code? See, peek is going to inspect the topmost value. Now how can I inspect the topmost value? First I will pass the stack to the function and then to inspect topmost value I am going to definitely consider this part of the code and find out if my stack is empty or not. In case if it is not empty, then what is to be done is the function simply needs to return the topmost value. Since I am just inspecting what is there on the top. Without removing it. For that, I have written num.pop. Now let us quickly execute the program and let us check how it functions. So I've saved my program. Let me see if I'm able to do. I'll choose the option 1 to first create a stack. So I've taken 23.5 as my first element, and I will again push one more element, 45.5 in it. I would like to check if I have the elements over here or not. So here it says list object is not callable. Yes, I need to change this to the index number, and I'm sure my function is going to work. Let's execute again and check. So here I'm putting one element, inserting an element. Again, I would like to insert an element, so I'm going to put 34.5, and display is 4. Oh, so let me come out of the program. Let me write print over here. And perhaps now my program is going to work. Let me insert another element and check for the first time only whether the element has been inserted or not. You see the element has been inserted, and to check whether it functions like a stack or not, let's see. Now my first element is 45.5, the second element is 89.5, and if I wish to see, you will see that the first element to be put was 45.5 and the second is 89.5. So on the top we have 89.5. This. So that's all. Thank you so much for watching the video.